As I start recording, the first thing I want to ask is, does anybody have questions on anything? Does anybody have questions on any of the homework questions? The other section started, it took us about 5 minutes to go through all the questions they were wondering about in that P1. Does anybody want to look at those? Okay, Gianna, if you have a question, put it in the chat. Thanks. Gotcha. Anybody want to look at anything from the homework?
When do we have do we have quizzes and stuff?
You know, perfect timing. I did not pay you to ask that question.
You did.
Yeah, I'm gonna switch to screen share, and I put a little bit of information in the top of the notebook where I'm putting today's notes. Today we're going to look more at algebraic expressions and exponents. We're going to have a quiz next class. The quiz is going to be this quiz. It's going to be a little bit different from time to time. This quiz is going to be in my math lab. With this quiz, you will only have one chance to take it. There will be no help functions. I will also create a drop box in Blackboard. And what I'll do on Friday, I will show you how you can take a cell phone picture and submit it in the Dropbox. I'm not going to have you take the quiz during class time because I know that different people have different levels of connectivity. And so you'll have any time from the end of class until the end of the day on Friday in which to take it. If that's problematic for anybody, please send me an email by Friday and we'll try to figure something out.
So is this like the quiz during class time, you said?
No, it's going to be outside of class time, not during class time. Because I was initially going to have it during class time, but then I know there's some people whose, well, like my internet got overwhelmed today and in the middle of class because I had two computers on, everything crashed. And I don't want anybody to run into a problem with crashing during the quiz because they're Zooming and quizzing at the same time. Do you know what I mean?
Okay, so we can just take it anytime on Friday?
Anytime after class on Friday.
Okay, cool. Thank you.
In class, I'll show you how to submit your work. Please notice that I pushed the due date back for homework 2 because we hadn't quite gotten to that content yet. No questions on homework 1. That's to be done by the end of the day today. Oh no, I lied. By the end of the day tomorrow. If not, I'm going to pick up from where we left off last class. And if I remember it correctly, if I made my annotation right, last class we left off with just defining what like terms are. And the reason we need to know what like terms are is because we're going to have to combine like terms. And when we combine like terms, what we actually do is we use the distributive property backwards. I'm hoping that everybody's kind of seen this before, but let's go through a couple of examples to make sure that everybody's kind of on the same page. So let's say, for example, I have something like 2x plus 3x. To start with, are we all in agreement that they are like terms? They have the same variable with the same exponent.
Yeah.
Now, when I say use the distributive property backwards, you can write this middle step down, but you don't have to. Wouldn't the distributive property tell us that that's the same as 2 plus 3 times x? If I were to distribute with what I just wrote, wouldn't it take me back to where I started?
Yes.
And now order of operations says do what's in parentheses first, and 2 plus 3 is 5. So that gives me 5x. And so if I have like terms, I add or subtract, depending on the operation, the coefficients. And the variable part stays the same. So I think of it as addition being very mean. Addition and subtraction
Here, honey.
are mean in as much as they're very discriminatory.
Here,
They
take
only-
this here and go get ready for your next class.
Okay, could you mute unless you have a question, please? I think they're very discriminatory because you can only add if it's somebody the same. They have to be exactly the same and it stays the same. So let's look at some more examples. So let's say I've got something that says simplify, and I've got 2xy plus 4 minus 3xy. Are they all like terms?
No.
No. But are there some like terms?
Yes.
And so I can combine those like terms. Again, you don't have to write this middle step, but if you want to, you can think of using that commutative property of addition to rearrange those last two. So now I'm going to add my like terms together. 2 minus 3 will give me negative 1xy plus 4. And you can write that just as negative xy. Oh, hello. You can write that as just negative xy plus 4. It would also be acceptable if you wrote that as 4 minus xy. They're all interchangeable. That one, all right. The other thing that we have to remember when directions say simplify, you have to follow your order of operations. And so, for example, if I have 5 parentheses, 3x plus 4, close parentheses, minus 4, when I say use your order of operations, if you think of your PEMDAS, or you please excuse my dear Aunt Sally, the pieces that were supposed to start inside the parentheses. But I'm looking inside the parentheses. Are those like terms? Can I do anything with them?
No.
No, they're not. So what we're going to do, if we've got things in parentheses that are not like terms, is after parentheses, exponents, there are none, then multiply. And so what we'll do is we'll distribute to get them out of the parentheses. So 5 times 3x would be 15x. 5 times positive 4 will be positive 20. And now they're no longer in the parentheses. And now I do have some like terms at the end. And so is everybody all right here? My final answer would be 15x plus 16. Another example, if I have 7 parentheses, 3y minus 5, close parentheses, plus 2 parentheses, 4y plus 3, close parentheses, and I want to simplify. Again, Order of operations says do what's inside the parentheses. Can I do anything inside those parentheses? Are they like terms?
No.
Can I do anything inside these parentheses? Are they like terms?
No.
No. So what we need to do is we need to distribute. With the first parentheses, we'll distribute the 7, which gives me 21y minus 35. With the second parentheses, I'm going to distribute a positive 2. So that's going to give me plus 8y plus 6. And now, all that's left is addition and subtraction, and we can combine like terms as they come. And so let's see, the y's are the same. 21y plus 8y will give me 29y. And then the negative 35 plus 6 will give me negative 29. That one all right. Next one gets a little bit trickier. If I look at 3 parentheses x squared plus 2x close parentheses minus 7 parentheses x squared plus 6x, then order of operations tells me to start inside the parentheses. Here, inside the parentheses, I do not have like terms. And so to take them out of the parentheses, I'm going to have to distribute my 3. And so that gives me 3x squared plus 6x. Now here's where we have to be a little careful. With this one, inside the parentheses, I don't have like terms, so I can't combine them. What I'm going to distribute is not 7, but that minus sign is attached to the 7. So over here, I have to distribute negative 7. So be careful if there's subtraction. Here we have to distribute the negative. So negative 7 times x squared is negative 7x squared. Negative 7 times positive 6x is negative 42x. So far, so good.
Yes.
Now, like terms, 3x squared minus 7x squared gives me negative 4x squared. Positive 6x minus 42x would give me negative 36x. There's all sorts of strange things popped up. And I lost my toolbar. And I just want to pull open that chat in case anybody asks a question in the chat. Right now, is everybody okay?
Yes.
If so, I'm going to add a
Yep.
page, look at a couple more. Next one. Let's say I have 14x squared plus 5 minus brackets 7 parentheses x squared minus 2 close parentheses plus 4 close brackets. How fun is that? Order of operations, we have parentheses inside parentheses. So we're going to start with the innermost first. When I look at that innermost set of parentheses, are those like terms? Can I combine them?
No.
No. So we're going to have to distribute the 7 to that first set of parentheses. And so that's going to give me inside the brackets 7x squared minus 14 plus 4. And the rest of the problem is going to stay the same. Now, inside those squared brackets, do I have any like terms?
Yes.
Yeah, the minus 14 plus the 4 gives me inside those brackets 7x squared minus 10. And the rest of the problem's still the same. 14x squared plus 5 minus that. Now, what's left inside those brackets? Are they like terms? No. So we've got to take them out of the parentheses. And over here with the subtraction, what we have to do is distribute a negative 1. So over there where there's that subtraction in front of the parentheses, when you have just subtracting in front of the parentheses, I like to write a 1 in there. And now the way that's written, it tells me that I need to distribute that negative 1, which gives me 14x squared plus 5 minus 7x squared plus 10. And now I don't have parentheses anymore. I don't have exponents to evaluate just on a variable. I don't have any more multiplication or division other than if you think of the coefficients as a multiplication. So now I'm going to add and subtract by combining my like terms. And so here our final answer is going to be 7x squared plus 15. That one all right?
Yes.
Everybody else okay too? I can't.
Yeah.
I have a question.
Sure.
So where it says 14x squared and the 7x squared, how do you know when to add them and when to subtract them? Because in the one before, you combined them by adding it together to get the answer. And this one, you subtract it. So that's where I get stuck.
I guess if you want to, you can sort of always looking at it, blah, I can talk, sorry about that. You can kind of always look at it as adding. However, it's not letting me change color of my pen. There we go. However, over here, do you see how that 7x squared has a negative sign in front of it?
Mm-hmm.
And so I can think of that as positive 14 plus negative 7, or I can think of that as 14 minus 7, either way.
Okay, gotcha.
So if there's a minus sign in front, you can either think of it as adding a negative, or you can think of it as subtraction. If it's all pluses, then you're just going to add. All right?
Yes, thank you.
Great. Then if those are all right, let me give you guys just one more to do on your own, and I'll shut up while you work on it. And sorry about that. Go back over it in a minute. So let's say we've got 6 minus 5 brackets 8 minus parentheses 2y minus 4 close parentheses close bracket. And I'm going to shut up and have you folks work on that. While you do that, does everybody have the problem written? This is beginning to go really, really slow. So while you're working on that, I'm going to try to shut some of the other windows that I have open in hopes of getting the computer to go a little bit faster. Everybody got the problem written down?
Yes.
All right.
Yes.
Yeah, the pen's keeping up with my hand now. It was definitely getting jet lag.
Hello, can you hear me?
Yep.
I just want to say that I'm sorry that I'm late. I had to fix my account because it wasn't letting me join. So I had to go to someone at the school to figure that out.
Okay, can you give me your name and I'll make note of the fact that you're here?
Olivia Navaroli.
Okay, Olivia. We got
I
you.
emailed you as well.
Okay, all right. I didn't see the email because I was in class, but
Yeah, I know. I just emailed you so you can see it later as well.
okay. I've got you down in attendance, and I will hopefully post a YouTube recording of the class before the end of the day so that you can see what you missed. Okay, hon? Thanks for letting me know.
Thank you. Sorry
And
about that. I didn't know what happened with it. The first time it let me join, and then today it was not letting me. So I went to someone to see if they can fix it.
Did they?
Yes, they fixed it because that's the reason why I can be in here now.
Okay. If it makes you feel any better, it's just been one of those bad technology days in the middle of my last class. My house lost the internet, and it took about 5 minutes of like pushing every button on every device that I can within reach, and calling my husband because he was at Spectrum already. And I was so happily surprised that they all waited for me. When I got back, the whole class was still there. It made my day. But all right, how are you guys doing with this one? Anybody got an answer yet?
Negative
Yeah.
54 plus 10y.
Okay, you can write that as negative 54 plus 10y, or you can write that as 10y minus 54. They're both the
Well,
same.
I thought it was my phone, but I tried on my laptop too, and it was doing it too. So I just knew it was like my account or something.
Yeah,
That's how I figured it out.
okay, but you're good now. So I'm glad you're here. Should we go over the details as to where that 10y minus 54 or negative 54
Yeah.
plus 10y came from? Okay, order of operations, where do I begin? Inside. Inside, where do I begin? Inside. 10y, I'm sorry, 2y minus 4. Are there any like terms there?
No.
No. So in order to get them out of the parentheses, I'm going to put my invisible 1 in, and I'm going to distribute not 1, but negative 1. So that gives me inside the brackets 8 minus 2y plus 4. The rest of the problem is going to remain the same. Inside those brackets, do I have any like terms? Well, I think the 8 and the 4. So combining them gives me 6 minus 5 times, what is that? 12 minus 2y. Now there are no more like terms, so I'm going to distribute to get rid of those brackets. And this time what I have to distribute isn't just 5, but negative 5. So that gives me 6, negative 5 times 12 is minus 60. Negative 5 times negative 2y is plus 10y. And then the 6 minus 60 are like terms. And so that's what takes us to negative 54 plus 10y. And you can also write it as 10y minus 54. Usually we kind of put it in what's called descending order so that the variables come before the constants. Better?
Yeah.
All sorts of practice like that on the homework, and not gonna lie, the reason that I originally intended for that quiz to be today, but I knew we hadn't done these yet, so there will be something like this on the quiz on Friday. And so if you've got problems with them, either use that Ask My Instructor, or make sure you get those questions clarified at the beginning of class on Friday. Where we're going next, we're going to add a definition, a couple definitions. First, we're going to add that of an equation. We've kind of just been working with expressions. Does anybody know the difference between an expression and an equation?
Equation has an equal sign.
Beautiful, I love it. An equation has an equal sign. So if I have an equation, pardon me, what I do is I set two expressions equal. And in a couple days, we're going to start looking at solving all sorts of different types of equations. Some pretty straightforward and some rather involved. But where equations come into this homework one is with the idea of a formula. And I think everybody's probably made use of a formula at some point in time in their lives. A formula is an equation that shows the relationship between variables. And so we could look at an example of a formula. And the example I'm going to look at is F equals 9/5 C plus 32. Question: has anybody ever seen that formula before?
Yeah.
Yeah. And so that formula actually shows the relationship between temperatures. F is the degrees Fahrenheit. And C is the temperature in degrees Celsius. And the way you're going to find equations as formulas in the homework is you're going to have something like that given, and you'll be asked to find the degree Fahrenheit if it's 9 degrees Celsius. And while this is an equation, what we're really going to just do is what we've been doing. We're going to substitute 9 for C, and then we'll simplify. So again, my formula is F equals 9/5 times, we're going to put in 9 for C, plus 32. And again, whenever we simplify, we've got to remember to use our order of operations. The order of operations says start with inside the parentheses. Here, there's no work to be done. Exponent. Could everybody mute unless you have a question, please?
I've been looking at those.
And exponents. After exponents will multiply. 9/5 times 9 would give me 81 plus 32. 81 divided by 5 is going to give me.
Michael, can you please mute yourself?
Mm-hmm.
Thank you.
16.2 plus 32.
Yeah.
And when I add, my final answer will be 48.2 degrees Fahrenheit. And so the equations that you're going to see in P1 are much more, again, just substituting a value and simplifying. They're kind of some practical applications of what we've been doing. All right? That one okay?
Honestly, I lost you that whole time because I couldn't hear anything you were saying.
Okay, sorry about that.
Nah,
So,
you're good.
you're given this formula. And the directions, I'm sorry, take that back. We're given this formula. And the directions ask us to find the degrees Fahrenheit if we have 9 degrees Celsius. What we're going to do is we're going to substitute the 9 for the C, because C stands for the degrees Celsius. So F equals 9/5 times, in place of C, we'll put our 9 plus 32. And then we're going to simplify using our order of operations. So 9/5 times 9 is 81/5 plus 32. 81/5 is 16.2 plus 32 gives me 48.2. So we're really just, over here, we're just being told to substitute and then we simplify. Better?
Yeah, thank you.
Okay, thank you for asking. If those ideas are all right, then the next place we're going is section P2. And P2 deals with a lot. It starts looking at exponents. And it looks at scientific notation. And then we go and start looking at radicals. So there's a lot in there. I know first day of class we did a little bit of using exponents and looking at where a negative fits in, but let's go through and do a little bit of definition and go over our exponent laws.
Is the quiz going to be just on P1?
Yes.
Okay, thank you.
So if I write something like b to the n, first of all, is everybody familiar with the terminology that b is called the base? And can anybody help me remember what n is called?
Exponent?
The exponent. And exponentiation is just a shorthand way of showing repeated multiplication. It means we're going to take the product of n factors of b. So what the hell does all of that mean? If I look at an example, what if I have in parentheses -2 to the 5th power? I think again earlier last week we talked about the importance of those parentheses. What that says is my base is -2, and the 5th power means I want to take that -2 5 times and multiply. -2 times -2 is +4, times -2 is -8, times -2 is +16, times -2 is -32. And again, if you can do the multiplication in your head, great. If you can't, hopefully you have a scientific calculator and you know how to get to the exponents on your calculator. If you have a calculator like mine, to do exponents again, it's that caret up, that arrow up button. If you don't have an arrow up button, you should probably have it. If you have a scientific calculator, you should have a button with something like x to the n or x to the n.
I have a question.
Sure.
It's just about using typing something in the scientific calculator. I did it one time in my algebra class in high school, but I forgot how do you do one with like fractions, like if you're like typing in a fraction or something. Like I just don't know what button to press.
Okay. One way you can do a fraction on a calculator let's say I have that fraction 81/5. One way you can enter it in your calculator is 81. And then if you use your division symbol in your calculator, it'll look like 81/5. And that'll give you 81 divided by 5 and change it into a decimal. Another way, some calculators, 81, there's a button that goes something like A, B, C, and then type 5, and your display will look like 81, and there's like some sort of funny looking symbol there, 5. And if you hit equal, they'll turn that into 16 1/5, changing it into a mixed number for you. So you can use that A, B, C button, but I'm usually, because when you're putting those fractions in, you're evaluating things, I'm much more likely to just use the division symbol. All right?
All
What-
right, thank you.
What calculator should we have for this course?
You can have any scientific calculator you want. My favorite, the one that I'd recommend, is I'm going to stop sharing and I'm going to hold it up here. What I have here is, can you sort of see it?
Yeah.
It's probably one that most of you might have used even like middle school or something. It's a TI-30X. What I like about it is it's got 2 lines of display, so you can type something in and then look at the answer. And what's the beauty of that is if the answer isn't where you think it should be, you can go back and look at the display and see if you made a mistake typing. The other thing I like about it is it's solar, so you don't have to worry about the batteries running out.
So
I
we
know.
don't need a graphing calculator?
No, if you have a graphing calculator, you can use it,
Okay, thank
but you
you.
don't need a graphing calculator. I know some people have something like this. What I don't like about this is because you don't enter things the way you normally would, so that I would much more likely recommend that you get this. I think you can get this in the bookstore for under $20, but especially this time of year, the beginning of the school year, you can get these for well under $10 at some places like Walmart or Walgreens or Office Depot or something like that. So it's a really inexpensive calculator. If you want a grapher, you can have it. But if you're in this algebra class, if you're on that path to pre-calculus, calculus, and beyond, I don't think anybody that teaches on our campus uses the graphing calculator for those courses, so that this calculator should suffice. The only place where you might run into a faculty member that uses a graphing calculator might be in statistics. But other than that, there's no need to spend that much money on a calculator. All right? So, definition of exponent, okay.
Yes.
If so, we're going to look at some rules for computation involving exponential expressions. And the first law for exponents that we're going to look at, laws of exponents. The first law is going to be the product rule. Help! What operation do I mean when I refer to a product? Multiplication. And so we're going to try to generalize from an example to get a rule where if I have something like x to the m times x to the n. In order for this rule to hold, it's important that they have the same base. And I'm sure that some of you probably can remember this rule and tell it to me right away. But what I'd like to do is I'd like to start by looking at an example and approach the example in sort of a little kid way, and so that the rule makes sense. So let's say, for example, I have x to the third times x to the fourth. Everybody all right that x to the third means I'm taking 3 x's and multiplying them. That x to the fourth means I'm taking 4x's and multiplying them. But it's all multiplication. So when I draw it out, 3x's times 4x's, how many x's am I multiplying all together? 1, 2, 3, 7. And if you can't remember the rule and you're a glutton for punishment, you can always draw it out like that. But looking at that problem, can anybody think of an easier way of getting that 7 from the 3 and the 4?
Add the 3 and the 4.
Add the 3 and the 4, add the exponents. If I take m x's and multiply it by n x's, altogether I'm multiplying x to the m plus n. So if it's the same base with multiplication, I add those exponents. I know that's not at all like a proof, but it's that example of enough of a verification for everybody to see and help you remember. When I multiply, I add the exponents, because I'm just counting up how many of those guys I'm multiplying. So for example, if I have x to the 5th times x to the 8th, if I multiply 5x's by 8x's, how many am I multiplying all together? 5 plus 8 would be 13. Now, one place where you have to be careful, if I just have, let's say, y times y to the 5th, this plain old y that has no exponents. Is everybody familiar that if it has no exponents, it means I have one of them? So plain old y is y to the 1st times y to the 5th. And so now when I add my exponents, I get y to the 6th. Usually you don't rewrite it with that exponent of 1. Usually people kind of just draw that 1 in there. I wanted to rewrite it so that when you're looking back in your notes, you can see that what we started with. All right?
I have a question.
Sure.
If y, like the first y in that is negative, then would the exponent be a negative 1? We
No.
subtract it?
Nope, 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 nope. If there's a negative exponent, there will be a negative sign in the exponent. If instead I had negative y times y to the 5th, that's the negative of y to the 1st times y to the 5th. Y to the 1st times y to the 5th is y to the 6th, and negative times positive is negative. If there's a negative in the exponent, and we'll get there before the end of the day today, I promise, it means something totally different. And if there's a negative in the exponent, the negative sign would be written up there on that exponent. Okay?
Okay, thank you.
All right, thanks for asking. Another example. What if I have 3 times 3 to the 3rd? That would be 3 to the 1st times 3 to the 3rd. Now I want to ask a question. As I look at that, do those two have the same base?
Yeah.
Yeah. Since they have the same base, does it make sense that we have to keep the base? There's some people who make a really careless mistake. Don't. The bases are both 3. The base on my result will be 3. When I add the exponents, I get 3 to the 4th. Now, if I want to evaluate, if you have a calculator, you can go 3 to the 4th on your calculator. Otherwise, you can use your fingers and multiply. 3 times 3 is 9, times 3 is 27, times 3 is going to give me 81. But please notice, even if the base is numeric, it stays the same. So another example, if I have 10 to the 3rd times 10 to the 2nd, my base is 10, it's going to stay 10. So that'll give me 10 to what power?
Okay.
And is everybody all right if I take 5 tens and multiply them? It means I'm going to have 5 zeros and my result would be 100,000. One last example that looks a little bit more involved. What if I have y to the second, x to the fourth, and I multiply it by x, y to the fifth? As I look at that, does everybody see that everything that's written there is multiplication?
Yes.
Since it's all multiplication, I can mentally regroup so that I multiply the things that have the same base. So don't necessarily have to write this next line, but if it keeps you from making mistakes, please do. I'm going to multiply my x's, x to the fourth times x to the first. Then I'm going to multiply my y's, y to the second times y to the fifth. And when I multiply, I add those exponents. So I'll get x to the fifth, y to the seventh. And again, because it's all multiplication, that's why I can regroup. That one all right?
Yes.
If so, after we look at the product rule, the next thing we're going to look at is the quotient rule. And the quotient rule, that word quotient, deals with division. So I could have x to the m over x to the n. And again, before I write the rule, I want to do an example to kind of show why the rule holds true. And for my example, I'm going to look at x to the sixth over x to the fourth. Where I have x to the sixth in the numerator, that means I've got 6 x's. 1, 2, 3, 4, 5, 6. And where I have the x to the fourth in the denominator, it means I have 4 x's. And now you have to remember, when you simplify a fraction, you can divide out common factors, which says that these x's, these cancel, these cancel, these cancel. And so what I'm left with are 2 x's, x to the second. And again, if you forget the rule, you can always draw it out and cancel those factors, those matching factors, to get the results. But wouldn't it be easier to say that 2 came from subtracting? And so the quotient rule says that as long as I have the same base, and again, it's important that they do have the same base. As long as I have the same base to divide, I subtract the exponents. So if I look at some more examples, if I have z to the 15th divided by z to the 6th, well, quotient rule says if the bases are the same, I'm going to subtract the exponents. Z to the 15 minus 6 would leave me with z to the 9th. That one all right?
Yep.
Let's look at another one. This time, let's look at 2 to the 12th over 2 to the 9th. And I have the same bases. So even if that base is a number, they have to be the same and it stays the same. I'll have 2 to the 12 minus 9, which gives me 2 to the 3rd. And then 2 times 2 times 2, 2 to the 3rd will give me 8. Looking at the juxtaposition, location of these two problems, I know I've got bad penmanship. I know that sometimes my 2's and my z's look a hell of a lot alike. Is everybody all right? If I want for it to be a z, there'll be a line through the middle. If I want for it to be a 2, there will be no line through the middle. So just a little key to my bad penmanship. But if the bases are the same, to divide, we subtract exponents. And so that rule gives us the idea of, I think we can put it on this page. It leads to the idea of 0 as an exponent. And I'm guessing some of you have seen 0 as an exponent before. Some of you have not. What does it mean if I have x to the 0 power? Well, let's start by looking at an example again. Let's say, for example, I have x to the m over x to the n. My quotient rule tells me that I'm going to subtract those exponents. But when I subtract something from itself, don't I get 0? But I'm going to look at that expression again. X to the m over x to the m. When I divide something by itself, doesn't it always equal 1? And since those two started at the same place, we're going to say that anything to the 0 power always equals 1, but there is one exception. And the exception to the rule is 0 to the 0 power is going to be undefined. Because 0 exponent tells me it equals 1, but we never want to multiply by 0 and get an answer that isn't 0. And so putting those pieces together, you can't. So 0 to the 0 power is undefined. So let's look at a couple of examples. Let's say I have inside parentheses 3,278,951 x, y squared, z cubed, all in parentheses being raised to the 0 power. Well, this is something big, bad, and ugly, but it isn't 0. So is everybody all right? Anything to the 0 power will always equal 1, no matter how big, bad, and ugly it is.
Mm-hmm.
And the reason that just equals 1 is because of those parentheses. Next example, which is one that trips people up a little bit. Let's say instead I have something that like negative 3x to the 0. And this goes back to what we were talking about last week, the importance of those parentheses. Are there any parentheses here? No. So the only thing that's being raised to the 0 power is the x. Order of operations, we simplify that exponent before we multiply. So that's 1. And then I've got negative 3 times 1. So this one, it equals negative 3. So, moral of the story, if there's parentheses and the whole thing is being raised to the 0 power, it equals 1. If there are no parentheses, the only thing that's being raised to that power is the factor that's closest to the exponent. And so we'll take that 0 power to get 1, but then we have to multiply by what's left. Everybody see the difference between those two examples?
Yes.
In addition to 0 being an exponent, and I apologize, I forgot who asked, but somebody earlier was asking about negative exponents. And so what we're going to do now is we're going to give meaning to something like x to a negative n. What does it mean when I raise something to a negative power? And again, I'd like to start with an example to kind of explain why it works. This time, let's say I've got x to the third over x to the fifth. If I use that quotient rule, that's x to the 3 minus 5, which would give me a negative exponent. But if I go back and look at the definition of x to the third over the definition of x to the fifth, x to the third means I've got 3 x's in the numerator that I'm multiplying. X to the fifth says I'm multiplying 5 x's in the denominator. If I were to simplify that fraction, some of those x's cancel out. And what I'm left with are 2 x's, but they're in the denominator. And because these two started at the same place, it tells me that those two are equal. And so if I have something with a negative exponent, it means I'm taking the reciprocal. It means I've got 1 over x to a positive power. So if I have a negative exponent, it means I'm going to take the reciprocal. I'm going to put 1 over x to the absolute value of that exponent. So for example, if I have y to the negative third, by definition, that means 1 over y to the third.
Can you slow down?
Sure. I'm not used to talking all day yet, so slowing down gives me time to take a cough drop. My throat's a little scared. So sorry about the wrinkly wrapper noise. Are we all caught up?
Yeah.
Okay.
Nah.
Now, all right. Let me know when you're ready. We good now?
Try another 10 seconds.
Okay.
All
Aren't the
set.
lectures recorded?
Yes.
Okay.
So if you want to just, if you're having a hard time keeping up writing and you want to just pay attention, the lectures are recorded unless I forget to press that record button at the beginning of class. So remind me to do that. They'll be uploaded as YouTubes unless my computer crashes. And a lot of them must this, right? But the written word will just negative exponent means 1 over. Okay, let's see if there's anything else I can close, you guys. Love to close. Let's say I have, and with these, the directions are always going to ask you to write with a positive
Hello,
exponent.
sorry, can you repeat that? You're really cutting out for me for some reason.
It's because I've got two. Oh. All right, we're trying. The directions might ask me to write with positive exponent.
I can see the screen okay, but the voice thing is cutting out.
In order to fix that, I'm going to have to take a minute.
Sorry, I can't understand what you're saying because of the voice thing.
Is that any better after closing a couple other things?
Yes, thank you.
Okay, I apologize. I didn't delete yesterday's notes and the computer only has so much memory. So the directions might ask, write with the positive exponent. And I might have something like x to the second, y to the negative third.
Nope, actually it's happening again. I don't know what's going on. It's like 1 minute you're there and it's working, and then the next it's very cut out.
I apologize. I think it's the internet in my house, the way I lost the other class. If you guys are having a problem hearing, should we stop here for the day and pick up on Friday?
Is anybody else having this issue? Is it just me? Is it my account
No,
maybe?
No, it's not just
it's
you.
me too.
Me too.
Thank you for pointing it out. I will try to save those files from the earlier class earlier next time so that this won't happen. I'm very sorry. We'll stop and we'll pick up from here on Friday. Okay?
Okay.
All right.
Okay.
Thank you for pointing that out, because if you can't hear me, it's silly for me to carry on. Have a great day, you guys.
You too.
Thank you. Have a good day.
You too.
So yeah.